2319 project, we decided to replicate Papa's Pizzeria, rebranded as Just Toast Pizzeria. As with the actual game, we have 4 stations: order, build, bake, and slice. The entire playthrough is too long to fit within 5 minutes, so we will simply be showing some highlights. In the main menu, we may toggle between English and Spanish language options. Now, for the gameplay. First, at the order station, our first customer, Wally, gets his order taken. His picture and order are recorded in the pink ticket at the top of the screen. Having lived his entire existence in a post-apocalyptic world, he has had very little interaction with plants and is eager to try pineapples for the first time. We are not monsters, so we're not going to make you watch the pineapple toppings being added in real time. From there, we move to the bake station, where we wait for the timer to match the expected value on the ticket. Finally, we move to the slice station, where the accuracy of the cut depends on the accuracy of the white slider. Finally, Wally gets his pizza! Yay! Now let's go into a little more of the underlying mechanisms.
Jank transition.
Firstly, the most frustrating aspect to implement, and yet the greatest source of pride, the cursor. We modified many of the functions the ST7735 driver our professors gave to us, most notably bitmap. It now takes an additional array pointer parameter, the preimage, which would be calculated every time the cursor was updated and was the same size as the cursor. An if statement then outputs either the color from the image or the preimage, dependent on the black pixels in the image. From there, copying the matrices was pretty much just math, made more difficult by the default storage of bitmaps as one-dimensional arrays. However, the nature of our game posed a few additional challenges. Perhaps the most challenging one was that we wanted to be able to store the topping locations. In other words, we needed a dynamic background, even though most of our images were stored as constants in ROM for efficiency. Originally, we were worried about slowing down the processing speed and wanted to have a global array. However, we quickly learned that 1. That method is a tremendous memory hog, and 2. Computers calculate things pretty quickly. Instead, we stored an array of topping types and positions. Then, when calculating the preimage, we would check if the cursor was on the pizza to copy over the pizza base image or the background image. And if it was on the pizza, then we would loop through the array of toppings, checking the proximity of the toppings and load them accordingly. Since various images were different sizes and had different positions on the screen, the display allocations we created during our planning period were crucial, especially later on when we realized that we were running low on memory and made certain backgrounds solid color, so that the cursor had to check if it needed to copy a stored image or a background color. The rest of the display was much more straightforward, as we developed a pizza class during that initial period and were able to pass pointers to arrays of pizzas between files to display the pizzas on different screens. For instance, for the slicing station, we simply needed to reprint the image of the pizza base, then increment through the topping array, calculating and printing out toppings. For the baking station, as well as the image in the top 40 pixels for the customer ticket and the customer close-up in the ordering station and grading sequence, we wrote new functions in the ST7735 driver that allowed us to shrink and expand images, both for functionality and for lack of storage, though we later used a separate TM4C to implement sound. The timers in baking were dependent on a game clock, incremented in our SysTick interrupt, and the bake time stored in the pizza class. Through an array of 20 tangent approximations from 0 to 90 degrees, we created the effect of smooth timer animation, and set conditions for pixels to change color based on the time elapsed, with the center of each timer as the origin. Additional work for angles occurred to draw sloped lines shown in the ticket and cutting the pizza. Overall, I'm quite proud of how our game turned out, though I'd definitely change many things if we were to do this again. For one, we could have turned to attempting image compression methods of using a lookup table to store the images as constant uint8t arrays rather than uint16t arrays, which would have the added benefit of not reducing image resolution while still having the storage space. We could further compress images by using frequency tables, which is perhaps where the benefit of using one-dimensional arrays comes in. Since we didn't do that, we could have stored the images as 2D arrays instead, which would have made certain calculations more readable. We also didn't initially realize that external existed, so we were passing globals with purely pointers to classes. Towards the end, as the deadline approached, desperation took over, and much of our code got incredibly messy. Not quite the modular programming we were going for. Still modular, somewhat. The display allocation was a good start, but we definitely could have also engaged in more planning, especially maybe a helper function to change the bitmap to use the coordinates of the top left quarter as the parameters to be consistent with the fill rectangle function, or even the approximate center point, which would have slightly facilitated calculating the topping score during grading. If nothing else, the slope line should have been implemented from the center point, not the top left, because trigonometry is only fun until it's not. This is Anna, my lab partner is Vivek, and if you are satisfied with our game, Just Our Pizzeria, then please vote for us. Thank you.